Okay, so now onto the back of our activity 19 and 22 test review. On the back, we did number 15 in class, we did number 17 in class, so I'll do number 16 for you. Just a reminder on how you solve these problems. The first thing we got to do is draw the triangles separately. And so I'm just going to do this one really quickly. There's my large, here's my medium, and then here is the smallest of these right triangles. These three right triangles in this diagram are going to be similar. They're always going to be similar when you have this situation. And so similar triangles have proportional side lengths. So we're going to set up proportions. You need to draw them separately and in the same orientation so you can easily identify the corresponding parts. So I can see that this short leg goes with that short leg with that short leg. It's very easy to identify. And then this longer leg goes with that one, and then obviously you've got your hypotenuses that are all corresponding to one another. It's much easier if you draw them separately and like this, in the same orientation. So now we can look at our diagram to label our triangles. The largest triangle, this is the short leg, so that's going to be Y. Our longer leg is going to be this, so that's Z, and then our hypotenuse is 6 plus 24, which is 30. Now moving to your medium-sized triangle, which is right here. This is the medium-sized triangle. The short leg, this is the short leg, is X. The long leg right here is 24. And then our hypotenuse is Z. Now in the smallest triangle, that's this guy right here. The short leg is 6. The longer leg is X. And then the hypotenuse is Y. Now that you have all the triangles drawn separately, solve one variable at a time. Solve for x first. I can see that the medium and the small triangles, those are the only two triangles that involve x. So those two are the ones you're going to use to solve for x. There's my medium, and there's my small. So X is the short leg of the medium triangle, and then I know that the long leg is 24. So write the variable you're trying to solve for and the side length that you actually know. On the small triangle, I know that this side length is 6, and then X. I'm trying to solve for that, so I'm going to go ahead and label that. Once we have this drawn, it's extremely simple to see that I'm going to use the corresponding parts and set up a proportion. 24 goes with X, because those are the longer legs. That's going to be one of my ratios. And then I'm going to compare the short legs of these two triangles. So I've got the longer leg from the small triangle, that's X. That longer leg is going to be corresponding with the longer leg in the medium-sized triangle. That's one ratio. Then the other ratio is going to be of short legs. Here, my two short legs. So that'd be 6 to X. Those are my two short legs. So I've got a ratio of long legs is equal to a ratio of short legs. On top are the values from my small triangle. On bottom are the values of my medium-sized triangle. From there, cross multiply and divide. X times X is X squared, and then 6 times 24 is 144. And then to get the variable x by itself, you have to take the square root, and the square root of 144 is 12. The next one, to solve for the variable y. The biggest triangle involves y, and then the small triangle involves y. So those are the two that I'm going to use to solve for y. On the largest triangle, I can see that my short leg is y, and then I know its hypotenuse length is 30. On the smallest triangle, the hypotenuse is y, and then I know my short leg is 6. So you write the variable that you're solving for and then the side length that you know. After you do that, it's quite apparent what your proportion is going to be. I've one ratio, so I got ratio set equal to ratio. One ratio is going to be of the hypotenuses, y and 30. And then the other ratio here on the right side is going to be of the short legs. So I've got hypotenuse to hypotenuse, hypotenuse of small, hypotenuse of big. Over here I'm going to have short leg of small and short leg of big. So on the left, that's a ratio of hypotenuse. On the right, that's a ratio of short legs. On top, all of those values are coming from my small triangle. On the bottom, all the values from the big triangle. Cross multiply and solve for your variable. I get that y squared is equal to 180. When you simplify the square root of 180, when you simplify that, you're going to get 6 square root 5. And then you'll do the same thing for z. You'll do the same thing for z. On number 17, make sure that you see that this whole thing is 100. So if that's taking up 36 of it, then what's left over is 64. And so for number 17, you would compare the medium-sized triangle and the smallest right triangle. And what you know on the medium triangle, you have that the short leg is 6, the long leg is 64. And then on the smallest triangle, you know that the long leg is x and the short leg is 36. So you would have long leg to long leg is equal to short leg to short leg. And you would get x squared is equal to 2,304. Take the square root on both sides, and that happens to be a perfect square, and 48 is equal to x. On number 16 here, again, it's helpful if you draw them out separately. So there's my largest, there's my medium. It doesn't have to be perfect, just as long as you get the side lengths and it's in the same orientation. So you got long leg, long leg, long leg, and then on the bottom, short, short, shorts, and then you got your hypotenuses that are slanted. So I'm going to label what I know. My short leg in the large one is right here, is 15. This is my longer leg, and then my hypotenuse is 25. On the medium one, which is right here, the medium, all I know is my hypotenuse is 20, and then z is the short leg and y is the long leg. For the smallest triangle, I've got that the short leg is x, the long leg is z, and the hypotenuse is 15. So we're going to use the large triangle to help us solve for these variables. We're going to use that large triangle because we know all sides. So to solve for, let's do it in alphabetical order. I'm going to solve for x. I'm definitely going to use the large triangle because I know all the side lengths, and then the small triangle involves x. So this is x, and then I know that the hypotenuse of the small one is 15. So I'm going to write down the corresponding side lengths for my big right triangle. The short leg is 15, and then the hypotenuse is 25. So there's my proportion. Hypotenuse to hypotenuse, short leg to short leg. And when you cross multiply and divide, you should get that x is 9. For y, we're going to use our large right triangle again because I know all of the side lengths, but the variable y is involved with the medium-sized triangle. So y is the long leg, and then I actually know the length of the hypotenuse, so those are the values I'm going to look at. And then I'm going to write down the corresponding side lengths from my big triangle. So this is 20, and that's 25. So I've got long leg, hypotenuse, hypotenuse. So here's a ratio of the long legs, 20 to y, and then I've got a ratio of the hypotenuses. This is 25 to 20. After you cross multiply and divide, you get y is equal to 16. For z, you can use, we're definitely going to use the large right triangle because it has all of its side lengths. That rarely happens, that we have all side lengths of one of these triangles. But the medium involves z and the small involves z. So you can choose either one. You're going to get the same answer. I'm going to choose the smallest one. I should not have written that. So what I've got is long leg to long leg and hypotenuse to hypotenuse. So long leg 20 to long leg z is equal to hypotenuse 25 to hypotenuse 15. And when you cross multiply and divide, you should get that z is equal to 12. Okay, last two is 19 and 20. Number 19, when you have this, this is an isosceles triangle. This is an isosceles triangle because 17, 17. And so that means my base angles are congruent. And when you draw in this altitude, the height, it actually creates two congruent triangles. You can prove that these two triangles here are congruent by using angle, right? They've got the base angles. So angle, angle, side. Angle, angle, side is why these two triangles are congruent. So that means by CPCTC that this segment is congruent to that segment. And so if that's the case, 16 divided by 2, this is 8, and that's 8. So each one of these congruent right triangles has a hypotenuse of 17 and then a shorter leg of 8. You can use Pythagorean's theorem to solve for the height. And so it's just, this is going to be your value of c, and then when you do that, you get that the height is equal to 15 meters, and then now we got to find the area. Area of a triangle is 1/2 times base times height. So our base is the base of this original triangle. So that's 16, and then the height we just found out was 15. And so when you do this, you should get 120 meters squared, because area is in square units. Number 20, it says, is it a right triangle? If it were a right triangle, then that means that c squared will equal a squared plus b squared. If it's a right triangle, then these will equal. If it's not a right triangle, then those won't equal. So let's test it to see if they really do equal. So right now, this is in question. I don't know if this is true. So plugging in the values, I've got the square root of 26 is my longest side. You can type that into a calculator and test it. It's more than 5. Well, the square root of 26 squared is just 26. 5 squared is 25, 1 squared is 1. So yeah, 26 does equal 26. So yes, this is a right triangle. The other two things that could happen is that c squared is greater than a squared plus b squared. That means the hypotenuse is longer, c is longer, and so making it an obtuse triangle. And then the other thing that could happen is c squared is less than, and that would mean that c is smaller, making that an acute triangle. Okay. That's all the time that I have to make a video, but I hope you guys do well on the test, and email me if you have questions. Email me if you have questions.